In this video, we're going to recap our understanding of conditional probability. So conditional probability is when we're given a condition or a restriction that changes the total number of outcomes in an event that we're considering. We know if we have two events, A and B, the probability of A given B means the probability that A will happen given B has happened. So this probability now is going to, instead of being out of the total, would be out of given B has occurred. So the total at the bottom of our fraction would be the probability of B. So if B has occurred, for A to occur, the top of the fraction is the probability of A and B, or A intersect B, that they've both happened given B has already happened. And this is our conditional probability rule that we use, or formula, that can come in very handy as we're going to see in the next few lessons. But let's just recap with some examples to show conditional probability. So in our first example, we have a bag contains 5 red marbles and 8 blue marbles. 2 marbles are chosen at random, one after the other, without replacing the first marble. So drawing a tree diagram of this situation, we've got a choice of a red or blue marble that we would choose. Now, they're not equally likely, so we have a 5 out of 13 chance of choosing a red and an 8 out of 13 chance choosing a blue. After that first selection has happened, our probability total outcomes changes because we're not replacing that marble. So in our second choice, if we have chosen red, or given that we've chosen red, the probability of getting another red would then be 4/12 on top of that, or a blue would be 8/12. But if we chose a blue marble first, then the probability of red would then be 5/12, and the probability of getting a second blue would be 7/12. So using our tree diagram, let's consider some probabilities. What's the probability that we get 2 red marbles in a row? So that's simply reading off that first branch of our tree diagram. So that's going to be, first one has a 5 and 13 chance, and the second being red is a 4/12 chance. So we get 20 out of 156. Now we can leave that as the value as our fraction. We can simplify to 5 over 39. It doesn't require us to, but if we do simplify, making sure we don't make an error. In our second example, we've got the probability of red and blue, a red marble and a blue marble. So in this case, we need to consider that we could get a red followed by a blue, or a blue followed by a red. So we've got 2 possible probabilities here that we need to consider. So in our first one, red first and a blue second, or blue first and a red second, and we could see that we get 40 out of 156, or another 40 out of 156. So we've got 80 out of 156 as a probability, or 20 out of 39. So let's consider this situation where we have a condition. What's the probability that a red marble is chosen second, given, and there's our given line, given we know blue was chosen first? Well, from the diagram, we can actually clearly see the answer to this problem. From our diagram, if we go given that blue has already been chosen, we know that we are reading off this first branch. If blue was chosen first, the probability that a second is chosen is simply 5/12. So this second column holds our conditional probabilities because we're not replacing, we have already chosen our first marble. So based on that condition, we can work it out. So we could say that the value of the answer to this would be 5/12 from the diagram. However, let's consider our formula. So the probability of A given B is the probability of A and B over the probability of B. Now I'm going to go through and change my A to what's the probability that we've got a red second. I'll put a little 2. So red second given we've got a blue first. So let's change that with a blue first. So using our probabilities, we could say if we want to find this, well, the probability of red second and blue first, if we go back to our tree diagram, let's make this a little bit smaller so we can see. Red second and blue first. Here we go. We're going to do 8 13ths times 5 12ths over the probability of choosing blue. The probability of choosing a blue marble is simply 8 out of 13. And when we simplify this, we can clearly see we will get 5 12ths. So whether we use our diagram or whether we use the formula for conditional probability, we'll arrive at our answer. So in example 2, we have a situation where we're given some probability values. So we've got 2 events, M and N. We're told the probability of M is a half, the probability of not N is 3/8, and the probability of M union N, or M or N, is 3/4. So let's use a Venn diagram to represent the information we've got so far. Because we're given probabilities, the universal set here will be out of a total of 1. So let's see if we can just use this information to fill out our Venn diagram. So our first piece of information tells us the probability of M is a half. So I'm going to place that up in my little semicircle there to say that whole event M is worth a half. Our second one says the probability of not N is 3/8, which therefore tells me that the probability of N will be the complement, 1 take 3/8, which will be 5/8. And that's our answer to the very first question. So I know the probability of N is 5/8. So I'm going to place that in that semicircle. Then it says the probability of M or N is 3/4. And I know that this probability of the or means the total of the circles involved in the Venn diagram, those 3 regions. So if they're worth 3/4, that tells me that the outside must be worth 1/4. So already we've got quite a lot of information here. So we found out the probability of N. We're asked to find the probability of M and N, which is the intersection in our Venn diagram. Now, because we know the totals and the outside region, we can use that addition rule to work out the center. Because we know that the probability of M plus the probability of N will always give us a little bit too much. So if we take away that intersection, it tells us the union. And we want to find that intersection. So if we rearrange this little rule to find the intersection, it would simply be the probability of M plus the probability of N, take the probability of M or N, and that will give us the intersection that we want. So this is equal to 1/2 plus 5/8, and then we're going to take away that union, which we know is 3/4. So obviously putting this all with a denominator of 8, 4/8 plus 5/8, take 6/8, and we're going to get 3/8. So that tells me the intersection is worth 3/8. This is really handy now because we can finish our Venn diagram. We know 1/2 is 4/8, so M only is going to be 1/4, and 5/8 take 3/8 tells me that N only is 2/8 or 1/4. So very quickly we can use that information to find those values. We could have also used those values in slightly different ways, but it's just how you see those values working for you. So now let's have a look at a conditional probability question. What's the probability of M given N? So using our rule, this is M and N over the probability of N. Using our Venn diagram, it just tells us that if we have the condition of we must be in circle N, where is M? And so straight away we can see that we've got out of circle N, we've got out of 5/8, we've got 3/8. So, well, 3/8 out of 5/8, that's just 3/5. But if we look at the formula, we can also look at it as the intersections were 3/8 divided by the total of N is 5/8. And obviously we would need to flip and multiply to get rid of that fraction divided fraction, and we end up with 3/5. So we can use the formula or we can look at the diagram. So now what I'd like you to do is pause the video and have a go at the next conditional probability. What's the probability of event M given not N? Okay, so looking at this conditional probability, this is saying given not N, and we already know what not N is. This is out of 3/8. So out of 3/8, where is N involved in not N? So I'm just going to put a yellow mark where not N is. Not N is here and here. Oh, and then I've simply made a very large mistake here with my number that I've just noticed. 4/8 take 3/8 is a quarter. Sorry, an eighth, not a quarter. That will be a little bit more helpful if we fix that up. Okay, so this is where not N is. So let's just verify that that actually adds to 3/8, and that's 2/8 plus 1/8. Yep, phew. So we've got our value here. So out of 3/8, where is M in those not N? And that's at 1/8. We can see that's where M and not N occur, and this is the probability of N. So we've got those two values. So when we multiply by the reciprocal of that denominator, we end up with a third. I've got one extra question for you that I thought would be really nice to have a look at, is when we're presented with no Venn diagram and with some probabilities. And these ones are presented with the answers to the conditional probabilities. So if I've got the probability of B given A is 0.2, the probability of A given B is 0.25, and the probability of A and B is 0.1, how do I find A or B? The union, the either part, the or part. So I'm going to take this first value of the probability that says the probability of B given A is 0.2. Well, we know from our conditional probability formula, this is the probability of B and A over the probability of A. And if we fill in what we know here, I know that this is 0.20. I know the intersection 0.1 over the probability of A. So what it allows me to do is actually solve for the probability of A. The probability of A is going to be 0.10 over 0.20, which when we times both the top and bottom by 10, the probability of A is a half. So, your turn. Pause the video and see if you can work out how we could use the probability of A and B, the second conditional probability, to work out the total probability of event B. Okay, so filling this out, the probability of A given B is the probability of A and B over the probability of B. What we know from these is that the probability of A given B is 0.25. We know the intersection is 0.10. But what we can do is find the probability of B. So the probability of B is going to be 0.10 over 0.25, timesing the top and bottom by 100 to get rid of the denominators. We've got 10 over 25 or 2 over 5. So this is fantastic to help us find the union, because we can use our addition rule that says the union is A and B take the intersection. And we know A now, we know B, and we know the intersection. So filling these in, we've got A is a half, B is 2/5, and the intersection is 0.10. That's just 1/10. have them all as fractions, we can change the denominators to all out of 10, just to make it easier. And we get the union of A and B as 8/10 or 4/5 or 0.8. So it just shows you that no matter how probabilities are presented to us, either as values of conditional probability or intersections, we can always use those formulas such as the condition probability, the addition rule, to help us solve the problems.